Okay, we've got two coils now. Just dropped something. Two coils, 2 meters, both meters, let's see, both set to kilohertz. And you can see each meter is on its separate coil. So those frequencies tie up. Right, so let's put them side by side. Easier. Oh, hang on. It's a bit fiddly. Trying to make room. Oh, I actually have to move it. Oh, damn it. Oh, I think that's it. I hope my meter doesn't fall on the floor. Right, okay, we're currently registering the frequency. Put this one on the... well, I'll leave that on frequency. Let's put this one on voltage. Right, that one's on. Let's check. Let's tie them both up. Let's put this on voltage as well. Oh, it wants to be on AC. Would help. Right. Okay. Well, I've got a slight difference. It's probably due to the fact it's AC. So AC is frequency dependent. So 1 meter might be more sensitive than the other. But it's actually reading 1.2. No, actually, one coil could be putting out a bit more power. That could be it. Yeah, so that one's giving out 1.32 volts. That one's giving out 1.23. Right, okay, so we're getting a bit more voltage on the... Let's see, which coil is that? I've got mixed up now. I think it's the one I've just wound, actually. So the voltage is a bit higher on the one I've just wound. Okay. Let's put this back on. Let's leave this on frequency, so we can see the speed. Right, takes a while for it to calibrate. Okay, right. Well, let's measure the current consumption. It's currently running. All nice and balanced at the moment. Oh yes, I forgot to mention earlier. What I did was I alternated the magnets, and I put some magnets on the back as well, just to balance things out a bit, just to test things out. But basically, the concentric magnet in the center, I alternated them. I put them north, south, all the way around, so that the magnetic flux, when it pulls, it will pull the magnetic flux that corresponds to the pulling effect on the outside concentric magnet. But the other ones that have been pushed will be diverted the other way to the other coil, up this way. So when that one's pulling, the magnetic field will be shunted from that way, and the other pole on here will be pulled this way. So we're getting more balance, much more balance. Right, okay, so we're 1.29 volts, frequency is 23 hertz. Let's put this to current. We're now drawing about 46 milliamps. Let's look at frequency. Frequency, it has dropped a little bit, just a little bit. Considering a short circuit of 50 milliamps, that's not too bad. No, it's not dropped. It's hard to, you got to wait for it to stabilise. We do get, I don't know what the waveform's like. I haven't put it on the scope. It could be sawtooth, it could be anything. But 22, let's put this back on frequency so we take the load off. Let's put that back on frequency. See what happens on here. So they're both reading 21. Frequency is going up slightly. So there is a little bit of lens effect. Mind you, I haven't got my rings on the end of the shafts yet, the drive shafts. That will make a big difference. So yeah, we are getting a slight amount of lens effect. Considering I'm shorting out 500 milliamps, that's not much. So 22 hertz, 23 hertz. Let's put the other one back on current. Not bad, really. That's not bad. Sorry, I'm trying to keep my hands still. Yeah, there's still things I need to do to this drive shaft as well. There's still some balancing to do as well. As I say, because when one side's pulling, the other side's pushing, and I haven't got my rotors dead balanced either. This one's a bit off centre. There's a bigger gap on here than there is on this one. So I'm going to have to move my rotors a bit. I'll just pause a bit and try and sort that out. Right, I've got my rubber, which is about this thickness. Let's see. According to this, I've got about 2 millimeters gap when I've got the rubber there. The other side, I can get this in. We've got about the same. So I've got my gaps equal now. I have to do it with the magnets sort of in between, so that they're equally pushing and pulling, so that both sides are equal. So I've got that balance now, and we'll get it running again. And it's actually starting by itself this time, which proves that it's much better balanced now. It's crucial to have it perfectly balanced, otherwise it takes a lot more force to get it started. And it's really starting up by itself, so that proves that we've got it more balanced now. Voltage is climbing. Current's climbing. We should get a bit more current and more voltage now. With it being properly balanced. We're at 20 Hertz. 19, 20 Hertz. 45 milliamps. Still accelerating. Check voltage. About 1.27 volts at the moment. 1.29, 1.3 volts. Yeah, we are. It is running a bit better now. 1.36 volts now. Almost at 1.4 volts. Wow. I haven't changed anything else other than balance the rotors. So a lot of this does depend on the rotors themselves and getting everything balanced between this side and that side. The seesaw effect, you've got to get it perfectly balanced. We're 23 Hertz. Let's put the load back on here. We're at 1.4 volts. Let's put the load back on it. About 50 milliamps. As I say, there's still some more work to do on the rotor couplings yet. 49 milliamps. 23 Hertz. And I'm only actually drawing current from one coil at the moment, so that's going to throw it out of balance as well. I wonder what will happen if I actually put them through my rectifier circuit. Oh, actually, let's see what happens if I put current on both of these. Actually, that might be a better thing to do for now. I'm just going to swap this over to milliamps. I'll put this on. Actually, put this on milliamp range. It's on the 400 milliamp range, but we're not going to read any current, so I'll swap this over. 1 milliamps now. We're actually drawing 48 milliamps out of that one. And we're drawing 43 milliamps out of that one. 45 milliamps. Let's see what frequency is on this one. We're still about 20 Hertz. Wow. I was basically just drawing 100 milliamps out of this unit. I was just drawing 100 milliamps by shorting them both out. and the speed can change. Let's go and check frequencies now. We're still at 20 Hertz, 21 Hertz. And I'm drawing 50 milliamps out the other coil right now. This one, you don't have to swap the leads over to measure current, because luckily it measures current on this one as well. This one's for the 10 amp range, that one. Now let's just put that on the current again. Right, we're drawing 45 milliamps out of that coil. We're drawing 48 milliamps out of that coil. 48 milliamps. And check the frequency. Remember, frequency is equivalent to RPM. And we're still at 21 Hertz. Wow, that's pretty good. Well, 11 minutes. My God, this video's at 11 minutes already. I'm just going to splice it onto the other videos and let you watch it all straight through, I think. There we go. My push-pull balancing effect does seem to be working without seeing any slowdown. Or any, I mean, there's no extra load on this end because this is current limited. I've got this current limited, actually. It can't go above that. Currently on. And there's a reason why I'm drawing more current than I was originally. Well, that's because my belt is too tight on here. I need to adjust. I moved my motor stator plate thing, and this belt is way too tight now. I'm going to have to cut this off and add it to another plate to make it adjustable, so I can slide it up and down and adjust the tension on the belt. We're going to see even more improvements when I do that. So there we go. We're at 22 Hertz. We're still drawing 53 milliamps out of the other coil. AC. We're on AC right now. Put this one on current as well. There you go, that's drawing 46.5 milliamps. I was drawing 48. Well, there will be a slight difference. When you draw current, there will be some losses due to the fact that it's taking inductance. It's taking inductance out of the steel, and obviously if you nick coil current from one coil, it's going to deplete the other one as well, because the inductance, the magnetic field, is shared. It's a balanced field. It's a balanced magnetic field, so it will actually deplete one of them, the other one, when you throw things out of balance. 47.5, 47.6, 44.8. Don't forget this. These are separate coils. These are both separate coils I'm running on. You know, two of them. Yeah. So I mean, if I put this a bit faster, we would easily get 100 milliamps or more. I mean, it's running pretty slow. Look at that. It's about 400 RPM. I did a check earlier, and it is actually 400 RPM, which is very slow. Okay, thanks for watching.